So right now is our panel session. The objective of the panel session is we want to make it more interactive and informal. The thing is, so that's the background. So 5 years of SWE, sensor web enablement, and then we had this vision about realizing the worldwide sensor web. We can just connect sensors together and then mix and match and create innovative applications. So the first standard was out about in 2007, and then so it's about 5 years for now. And then so I would take this opportunity to see to use this panel session to see, okay, so let's review what happened in these 5 years and what are the things we did wrong and what things we did right. And then the more importantly is, as a community, what should we do? As a researchers or practitioners, so what should we do? So next year, when we gather together again, we can say, whoa, in the past year we've done something. Really realizing make the vision, getting closer to the vision. Okay, so we have 3 panelists, and then I'll just ask them to introduce themselves. So can you introduce yourself and describe your SWE experiences? What's your role in playing SWE? So we can start from Carl.
I'm Carl Reed. I'm with the Open Geospatial Consortium. I've been in the GIS and geospatial technologies arena since 1969. I did my first computer map. Been a software developer, been a manager, been a CEO, been all kinds of things in my career. But about 20 years ago, I said I had enough of corporate America and time to do something else. And I started doing more work with the Open Geospatial Consortium, helping them facilitate the standards process. And 10 years ago, this year, I joined GeoCENS as a staff member. I'm responsible for helping the members get drafts, candidate standards through the process. So I answer lots of procedure questions. I'm also the Chief Technology Officer, so I work with other OGC staff looking at technology trends in the marketplace that might impact the development of our standards and the deployment of our standards. And I also do a lot of outreach activities, helping spread the information about the use of OGC standards in the marketplace. My last role, big role in the organization, is I also liaise with many other standards organizations. I've worked on helping develop standards, not just in the OGC, but in ISO, the IETF, OASIS, W3C, the Web3D Consortium, the Workflow Coalition, and on and on and on. Because location is hot, and everybody, it seems in every standards organization everywhere is doing something with location. The same holds true for sensors. As Steve mentioned, the OGC has had a focus on developing a framework of standards for sensor web enablement. The first standards came out about 5 years ago, and of course nothing happened for a while, but as happens with all standards, eventually people start implementing, especially as tutorials and reference implementations and things like that start appearing on the marketplace. Current status is OGC SWE standards. Most of them are in version 2. Hopefully Sensor Observation Service finishes up and Sensor ML finishes up here fairly soon, so we have a 2.0 baseline. My experience with SWE standards is I have no experience with SWE standards because I don't implement it anymore. I'm not a developer. My experience is more from dealing with the market and dealing with different organizations that are looking to implement SWE standards and trying to keep track of what is happening out in the community. And there is a lot happening with SWE standards. The problem is getting information on that. So every time several of us find information about the use of any OGC standard, we tag it using Delicious. So, for example, if you go to www.delicious.com and type in OGC doc plus SOS for Sensor Observation Service, you'll get about 50 references of the use of Sensor Observation Service in different applications, including good information, criticisms, issues, requirements, and so on and so forth. So there are a lot of resources out there to help you get information about SWE. Sorry for being so long.
It's okay. Yeah, thanks, Carl. And you know what? So if you have any questions about marketing or markets or SWE, business case and users, here's Carl. And Ilya. So Ilya has some slides.
My name is Ilya Zaslavsky. I work at San Diego Supercomputer Center and manage a group called Spatial Information Systems Lab. And I actually threw together a few visuals, but basically in the last several years I've been involved in many environmental observatory projects, mostly dealing with water observations, but also the project with observations in the ocean observatory system, critical zone observatory, and a few others. I'll show you a few things. Just to highlight some of the issues that we have been dealing with, of course, when we deal with water, observations come in many different forms and shapes, measured by different stations, by different organizations. The task is to bring them all together, and one attempt to do that has been through so-called quasi-hydrologic information system project. The experience of these projects sort of highlights some issues of sensor web enablement. We have to come up with a common information model for how we describe water data. We have to come up with common services standards so that we can retrieve this data. And then we actually need to convince the community that this is a worthwhile enterprise, and this is the toughest part, so that more and more people start sharing water data in this standard called WaterML. And then, of course, we found out that the WaterML that we originally designed, and that was very successful, is not OGC compatible. So the activity that we're now involved in, and this is a large international activity, is focused on standardization of water data exchange through OGC and through World Meteorological Organization. The focus is WaterML version 2, and in this case it is a profile of observation and measurements specification, which is one of these specs. Right, so keep clicking. The main, so a few words about hydrology, the main working group of OGC. This is one of the largest groups in OGC, I believe, these days. We have about 100 people that we meet regularly at OGC meetings. And the focus has been on development of, on refining SWE standards, in particular WaterML and SOS, Sensor Observation Service, so that the data can be confidently exchanged between different groups across international borders, across different agencies. And of course, when you have a larger group of people, there are a lot more use cases that we have to consider. And it becomes almost a never-ending process to come up with a standard. These are some outstanding issues that are listed on the right that we are still trying to decide whether we table them or try to address them in the current spec. And this is one of the key issues that all spec developers have to address. That's another thing that may be useful, given especially the talks in the morning. We need to have consistent infrastructure to translate measurements that we collect from sensors to our domain models. And this infrastructure has to be robust, scalable, and so on. One of such systems that we have been working with is so-called open source data turbine. That has been a project funded by NASA for many years, eventually became open source, and it's a way to interface with many different types of sensors, and at this point we also have to interface with quasi-WaterML. So this is an NSF-funded project looking for wider applications. And now something completely different. This is where SWE standards can play a very important role. This is the area that I've been working in for the last 10 or 12 years. If you have multiple maps of the brain and you want to analyze them sometimes in real time, there are actually a few startups that do that. They measure your brain waves. There are some devices that you can install, and it's not quite understand what's going on, but at least get time series and connect this time series with locations of the brain. How you specify location in the brain, because all brains are different. How you describe what you see. These are all questions that SWE Standards deal with, and this is potentially a growth area for what we're going to discuss here.
Yeah, thank you very much. And then Ilya has a very strong experience in the water domain, and then implementation experience in SWE Standard. Boyan.
Hi, I'm Boyan Brodaric from the Geological Survey of Canada with Natural Resources Canada, the federal department here. I'm both a user of SWE Standards, a contributor to some standards development in SWE, as well as an application developer for developing some software that's publicly available in the open realm for using some of the standards. So I cut across many of the boundaries there. I'm involved with the hydro domain working group with Ilya, so a current focus is on water, and one of my main projects within Arcan is developing the Groundwater Information Network, which is a national network for groundwater information across the country, which involves using SWE standards and other OGC standards to try and connect data for groundwater, both within Canada but also across the border with the US. And so that's led us down multiple roads, both good and some more questionable regarding SWE standards. In terms of contribution to the standards development, most of it's been along the same lines as Ilya here, and that is contributions to the water ML on the water side, but also on some GeoCENS standards for geology, and recommendations for changes to various standards as a result of various tests that we've done with those. In terms of application development, one of the areas of research actually that I work in is interoperability. And so we've been developing some solutions for being able to use these standards, but also integrate them for interoperability for very large data sets across the country. Thanks.
Thank you very much. And then we start the second question. Actually, it's a very start from abstract, because I believe that everybody has a different view about sensor web. So let's ask, so what does sensor web mean to you? So can you describe each sensor web in your own words? So Boyan, can you start?
Steve, do you want questions to be asked as we go along from the audience? Or comments? Or do you want to wait till the end for that? How did you
No, just wait. Let's wait.
Okay.
Okay, thank you.
Okay, well, I actually was going to probably take a slightly radical view here, in that I'm going to propose that the sensor web is mislabeled. And the reason I'm going to propose that is because it implies that it's about physical devices that are essentially taking stimulus from nature and translating it into some electronic signal. When what's been happening through the evolution of the use of the web is that it's tending to mean a lot more than that. It's tending to mean really any device or application that provides information about the physical or temporal properties of some physical object. So we're talking about anything that returns a value for temperature or pressure can be considered as part of the sensor web. So an example, for instance, is while a rainfall gauge might be seen as a sensor, obviously it's a physical device that's taking a measurement of some kind. In the sensor web, a lot of people are also arguing for the fact that something like a calculation for average temperature, which isn't a direct measurement, should obviously also be included. Or even a forecast, what's tomorrow's temperature going to be like? Obviously that's not a measurement because it hasn't happened yet, but it's something that could happen, and it's been forecast through probably a very complex model, for instance like a climate model. So in fact, what this leads us down to is this web stuff is not really necessarily just about sensors. It's really about physical measurements and the history behind those measurements and being able to obtain that information. A lot of that might come from sensors, but it's not necessarily the case. So in this way, the sensor web is really about physical devices that can measure the properties and their values, as well as derived applications that can also provide those values.
Thank you very much. Actually, yeah, so the focus is not only about sensors, right? It's about the data observations. So, Ilya, what's your view?
Being that this is very radical, I don't disagree with you.
Actually, I want you to screen.
Of course, we can look at sensor web at several levels. At the very first level, it's interface between devices and the models that we operate. And this interface is not very trivial, because if we map measurements that are done by sensors to our domain models, there are lots of issues here, how we map it structurally, syntactically, semantically, and so on. But we also want to, that problem has existed for a long time. You can connect to some measuring device, bring your data in and analyze it. That's not what sensor web is about. Sensor web really becomes powerful when you have multiple streams of data, and you can integrate this on the fly, so that you can create virtual data sets that you can analyze, mine, extract information from, something that was not available before. This is how the power of internet really came to be, and this is probably where the power of sensor web will be realized. Another aspect between, in addition to being the middle layer between physical sensors and our domain models and ability to analyze, is certainly two-way communication. So that now sensor web enables you to have sensors that will be automatically configured, and in terms of spatial frequency, temporal frequency, other characteristics given the condition that they're sensing. And probably when we're talking about a web of devices or web of things, device is a very abstract term here. People can be sort of devices, measuring devices in this model.
Yeah, thank you, Ilya. Carl?
Okay. There was a 2010 study, I forget exactly who did it, but we use it in a lot of our presentations, that right around 2012 to 2015, somewhere in that time frame, there's going to be 10,000 sensors out there for every living human being on Earth. So that's a lot of sensors. And a lot of these sensors express location. They all have location, obviously. And just to follow on the previous comments, sensor web is probably not the best term, because in reality, a lot of these things are not connected to the web. They're hardwired into physical manufacturing systems. They are available in a variety of other environments where there is no web. There may be a network, there may be radio systems. And there's this whole area now evolving called the Internet of Things, which Ilya sort of alluded to. And the Internet of Things means that everything's connected, and that everything can express itself through the Internet at some level. Now, the problem with all that is, and the things that like the OGC community is addressing now through a variety of domain working groups, is, yeah, it's fine to get a temperature, but what does it mean? What are the semantics? What are the characteristics of the sensor that created that temperature measurement, so that you know exactly what the constraints are and what you can use it for? What are the error elements? What are the uncertainties associated with that measurement? These are all things that need to be considered, because, as been pointed out already, what's really important is the ability to take that observation and related measurement and fuse it into some other set of information, so you can actually increase the value of that information. So a big area of work in the OGC community right now, and I'm sure in many others, is this whole concept of fusion. The fusion of sensor-related observations, either real-time or from archives, into larger models that have critical import to a lot of the things we do on a daily basis, and have major import in our future.
Thank you, Carl. And actually, I'm going to mix some questions together, so I hope you don't mind. Actually, my next question is, so we talk about sensor web and then your view, and actually a little touch about the value and why we need a sensor web. So right now, we want to follow this direction. So why do we need a sensor web? And what's the value? And then actually, what would be the killer app, you think, for sensor web? So for mass production, generate the value, you can say economic value or social and economic value. So what's the value of sensor web and what will be the killer app? Ilya, can I just start from you?
Put your hand on.
I try to be dynamic here, so.
Killer app is an interesting question. It has been asked so many times, and there are like hundreds of answers, and that probably means that there is no single answer and no single killer app that would exist for sensor web. But there are certainly a variety of applications where we can think of something that would be transformative and will improve life of people. That's what we associate with killer app notion, right? I would say that it probably will be in consumer sensors and something that will have immediate monetary benefits to people who buy into sensor web. The last slide that I showed was about brain, and that could be, given that devices are really small now, and you can, at this point, you cannot really transmit your thoughts wirelessly yet. But it's not that far from now. At least you can transmit your electrical signals that will be coordinated to locations in your brain. So if sensor web would allow you to monitor how your health responds to environmental conditions in real time. And we're dealing with aging baby boomers generation, so that could be the right time to focus on health applications like that. So health applications, of course, emergency response applications are very important, and this is where sensor web has already demonstrated that it can be helpful when you need to quickly integrate data streams from multiple sources, and you also need to configure these multiple sources to give you the optimal result. I probably can think of more applications like that, but if sensor web ties to something that is already in mass consumption, like you can Google killer app for iPhones, and I bet that quite a few of these apps will be related to sensors.
Yes. Yeah, thank you, Ilya. Actually, it's great. I get the idea about, we have a sensor, mobile sensors, and interact with the environmental sensors, and for health and aging issues, that's I see great value. Carl?
Okay. Killer app, I'm going to turn it around. I think the killer app is any use of sensors that prevents loss of human life. And that follows up with the emergency response, but it actually impacts many other areas, domain areas, such as defense or United Nations peacekeeping. Anyway, the largest area of deployment of OGC SWE standards right now is in crisis management, emergency response, and disaster management. There are numerous deployed applications, especially in Asia, for tsunami warning, earthquakes, debris flow monitoring, Himalayan glacial lake monitoring, all kinds of applications all through Asia. They've been really forward-thinking in taking and implementing truly integrated systems that incorporate input from a variety of different sensor systems, feeding that into modeling systems, which then feeds into alerts that alerts the citizens to get out of the way if something's going to happen, as well as getting all their livestock and perhaps other wildlife out of the way. So to me, that's a killer application. And that obviously brings more value than you can actually calculate, even in terms. Thanks.
Thank you, Carl. Boyan?
Well, this is a tough question. How do you measure killer app? Is it economic value? Is it human loss of life value? Is it gains in scientific knowledge, which are very difficult to estimate maybe for 100 years? So I guess you can go across all those dimensions. You can look at human safety, obviously. You can look at human comfort. You can look at scientific gain, and they'll be very different. But I think the one that hasn't been mentioned yet, really, so we've talked about all of those a little bit, but probably the biggest one is simply human entertainment. I mean, the possibility of sensors for things like gaming and virtual reality is enormous, and probably not touched that much yet in a wide scale in terms of remote locations interacting together. And you know, safety comes first, but it's probably looked at, it's treated when you have to, whereas entertainment is something that people do on a daily basis. So if you're looking at it from the point of view of popularity, it's probably something that has marketing or entertainment objectives.
Yeah, this is a great question. I will follow up. And Carl, do you know any SWE implementation for entertainment or consumer applications?
Yeah, there are a number of them out there actually. Sony Ericsson has an API that implements several OGC standards for use in iPhones and Android. I think Android phones now. So it can be used right now for gaming systems because there's an available API that gives you SWE access to, or OGC SWE standards access to all the onboard sensors on a smartphone. I believe there are 5 or 6 different sensors on both those phones. So actually there are some deployed applications out there, and you can just search on Google for them. But Boyan mentioned augmented reality. As a matter of fact, one of the OGC staff individuals, is in Basel, Switzerland right now at an augmented reality standards coordination meeting. Because it turns out there are a whole variety of standards necessary in the standard stack for augmented reality, one of which is the SWE suite of standards that has been brought up. But there's also another group that's really looking at a standardized API for the devices on your smartphones. There's a group called Chronos. They're developing they call it the Sensor Fusion API, which is a little misleading. Because when I first saw it, it was like, hey, what are they doing? We already got them. It turned out that all the handset folks have gotten together, and all the phone operating system folks have also joined the group, and they're developing a very low-level device level API for access to all the sensors on board your phone, which then could be wrapped in the OGC SWE standards. I already talked to them about that. And guess what their number one focused set of applications are? Gaming and augmented reality.
But it's still at the early stages, isn't it? The application. The application isn't out there being widely consumed yet. It's being essentially in the R&D phase right now.
Yeah, I think F2 North or IFTI, they have done something for virtual reality in SWE standard SOS, and then I think one of the key there is the data is not out there. So I talked to Christine, and she says, we have phone, and it can overlay the contextual information from the sensor about your environment. That would be great. But where's the data? That's one question here. So, but SWE is great about sharing those data, right? So right now I want to touch the SWE a little bit. So my first question is, what are the things you like about SWE standards from your experiences? I think mainly for Ilya and Boyan, the thing you like. You think we have done something right?
Well, if I can try.
Let's try to be nice.
Well, of course, standards, all the standards have problems, but there's I guess I will answer
the good thing about SWE. Yeah.
The bad thing is coming.
Yeah.
The next one.
That will be the next one.
Let's be positive.
No, the best thing is that they really exist, and they've been taken through the OGC process, and they became the foundation for, the simple foundation at this point, as far as I can tell, for bringing together different data streams. This is extremely important in earth sciences, because when we try to integrate observations that deal with, say, water samples and water time series and rock samples or geochemistry data, these are all different communities that normally don't talk to each other, or talk in a very superficial way. And but fundamentally, it's all observation and measurements, and there's a spec that defines some basic parameters of how you would describe an observation. Observation and measurement spec, that is part of SWE. So for water, there is water ML2, which is a profile of ONDM. There's a conversation about soil ML. There's a conversation about earth chemics ML being, that is for geochemical data, being based on ONDM standards. And of course, they will be still different, and they will have different semantics, and you will need domain scientists to interpret the data being transferred using these domain standards. But something will be in common. At least when you send an SOS request, you would get ONDM, observation and measurements type document, some profile back, and you will be able to understand something about it, even if you are from a different domain. And of course, it's an iterative process. Maybe communities will eventually come to higher level of agreement about about how they describe measurements. Maybe. But this is, to me, it's one of the key things about the standard, that this standard does exist, and there's a process behind this standard that allows everybody who is interested into their use cases being considered for that standard to come in and present these use cases and influence the development.
So, guys, if I may summarize, you like OGC with the process there, and you like the SWE standard because it's there, and then you like OM because it's nice and then fit into different domain.
Yeah, so shall we get to the second question?
No, we'll go to the Boyan next one. So Boyan, what are the things you like about SWE?
Well, I have to concur with Ilya. The best thing is that it's there. The second best thing is that it's managed by a neutral agency. Because that's what allows actual data providers, for instance, to be able to get together without too many territorial issues. And in the hydro group, we see this. We've got people from Europe, Australia, North America willing to come together, whereas on their own, that might be a little more difficult because there's always, well, we have to use mine, or we have to use yours, something along those lines. So that's the second best thing. The third thing is that there's actually slow and emerging adoption by key data providers. So, regardless of the technical problems, and we'll get to that, and others, there's adoption happening. And the problems are being smoothed out by people that are willing to do this together. So, so the adoption issue is, I think, a huge one. It's still a bit nascent in that we're probably at the leading edge right now, but it's clearly coming. So I think that's a really important thing. And then the fourth thing is that there are off-the-shelf solutions that are being developed, both in the open source and commercial arenas that you can actually use. So it's not just ideas at this point, there's actual technology behind it. And lots as a user, as a researcher, it's a good basis for interoperability research because you don't have to start from scratch and you have a way of being able to actually compare your results with someone else's because the foundation layers are largely the same. So I think that's been very valuable and opened up actually lots of areas of inquiry. And again, as a developer, I think it's useful because, again, there's one suite of things to develop towards, which narrows down the amount of work that you have to do greatly. But that's also one of the problems. So we'll get to that next, yes.
Just chopping the bit.
I also agree that because it's great because my self-promotion and my research group is focusing on developing the innovation behind the standard. So it provides a great platform for our researchers a lot here, and we can innovate behind the standard. And then so we want to talk about what the ugly things would do. Yeah, sure. Yeah.
Well, I can get right into the ugly things too, because I hear them all. Just to build on what both Ilya and Boyan said, I think the greatest thing is the fact there's a community there working together to foster the continued support and development of the SWE standards. We have great members, such as here on the panel. I know there's others of you out here in the audience representing many different domains coming together and collaborating on an international basis. Really provides a lot of value to the end product. because it serves the requirements of many different domains and many different sensor manufacturers. So yeah, we've got a good solid baseline out there. We actually call it the SWE baseline inside the UGC, which leads to the ugly. If you don't mind.
Sure.
The ugly is the fact that where did SWE really start? And what are its implications? SWE started out of the satellite community. Quite often now when people talk about sensors, they forget about all those things flying around up in space and in the atmosphere. Well, those are the sensors that collect a huge amount, petabytes of information on a weekly basis. And a lot of the original SWE work came out of the satellite community. Well, what does that do? Oh boy, that really requires massive amounts of metadata to describe the sensor and the processes related to the sensor. Much more so than gathering a temperature or an in-stream flow volume measurement. So when people talk, the biggest criticism we get of the OGC SWE standards is they're too complex, too heavy, and too hard to implement. And a lot of that comes from the fact that we do have a community for many different domains with many different requirements, from satellites down to the sensors on the phone, all trying to come up with a common set of SWE standards that meets the requirements of all those domains. So that's actually the good, the bad, and the ugly of it all rolled into one, at least from my perspective, trying to facilitate the standards development process. Obviously, you'll hear more from the implementation side.
Yeah, thank you, Carl. It's an introduction about ugly things, but Ilya.
Right. It may appear ugly only if you come from a use case that has been totally off and has not been considered within OGC process. So if you feel that they're ugly, please bring them in. Of course, the process may become the victim of its success. If there are too many use cases, the standard will never get developed. So we need to, scoping the standard is probably the most difficult thing that specification editors have to deal with. Indeed, everything depends on use cases. And when we try to use ONDAM and SOS and other SWE specifications in the water domain, for example, what looks scalable for Earth observations does not look scalable when we have to deal with, say, 23 million time series that we have in Quasi. Immediately, standard requests like get capabilities doesn't work, or we have to tweak the semantics of what we return on get capabilities and on other requests, so that we can fit our domain into this square peg, right? So how square it is and how the difficulties of fitting your domain, this is not a very exact measure of ugliness, but essentially that's what you have to decide, whether you have to come up with a different standard or move to a different specification, or try to adjust the semantics and come up with a series of change requests to enhance the current standard. There are certainly limits to standard. When they become too abstract and too omnivorous, they get to the level of not being very useful. And another big consideration beyond scope is how abstract you want your specification to be, so that because you need to balance wide applicability versus you need to give it to an implementer who will just follow the spec and make it work. So there's no simple answer to the question of what is ugly. It depends on your perspective, and it may very well be that your particular application, you have a small number of stations that serve somewhat limited number of time series, then it's perfect, right? Just take it out of the box. Or if you have something on the margins, and then you have to carefully think of what you do. And the best thing, of course, is to train the OGC process and make these concerns known.
Yeah, I feel about to say that. Join OGC process is fun. Just too many telecoms. Boyan.
So yeah, any big endeavor is going to be messy in the weeds, right? That's unavoidable. In the past, we've avoided taking on this challenge because we've tried to live in silos. And getting out of those silos, both in terms of institutional policies, in terms of technological solutions, in terms of data privacy and not giving data away, means that we have to tackle a whole set of messy things that we didn't have to before because we circumvented them by simply ignoring them. And so to some degree, what this process that we're engaged in is not ignoring them, and that's going to be messy. And so I think it's going to be an evolutionary process, and some of my comments here were right along what Carl said, backed up by Ilya, that through extensive use and implementation of the standards, and by the way, the systems that certainly I'm involved in building, and I know Ilya now too, are heavily reliant on these. So the comments right now are more about what we're seeing in terms of going forward rather than in terms of this is not a good thing. It's a good thing, it's just there's parts that need to be evolved. So, there's too many standards, they're too complex, they're too hard to implement, and they're too hard to learn for a lot of people. That would be the synopsis, I think, in many ways. Part of that has to do, for instance, with this notion that Ilya was talking about, general versus specific, that contrast. Because what we're finding is the standard represents a standard, yet there's many ways to implement it. So in order to implement it consistently amongst communities of users, there still has to be internal agreements made to implement it properly to get interoperability. So the standard out of the box won't guarantee you necessarily interoperability. It seems to require more specific agreements within the rather broad areas of the standard to be able to make it work. And this may be unavoidable to cover generality, but also allow for very specific goals of projects. But it does pose a problem when people jump into it at the beginning. I think there are also several issues that are related, that are not technical, but they're more related to social barriers. For instance, organizations don't necessarily have the technical literacy to deal with Web 2 yet, with web services, and that's still a barrier. They're at websites, not necessarily web services. And so they don't have policies in place that can deal with that, so that even if you ask them to put web services up to try and deploy some of these standards, they'll come back and say, well, we don't know how this will impact privacy and how our data will be used, because people aren't coming to our website to get it necessarily. It's being harvested by other machines and incorporated into other websites. So there's a range of policies that are being raised. And these aren't necessarily with respect to SWE, this is with respect to organizations' inability to deal with essentially Web 2 in some ways. You're itching there, I have another point.
Yeah, sure.
Let me finish up here. And so I think that what that raises is the need maybe for some kind of lighter version. Because there'll be heavy duty users and lighter users. It's sort of for those of you familiar with it, the debate between GML and KML to some degree. There are, the heavy use of GML is necessary for more complex data, but for some simple things like Google Maps, KML made it preferable for various reasons. And so we might have to look at something like that down the road, analysis.
Thank you very much. I think the agreement here is it's very complex, it's heavy, but it's unavoidable, right? And it's a good thing, not a necessarily bad thing. And then, and Boyan suggests that, the lightweight might be interesting. Lightweight SWE might be interesting direction. And then we also agree that the OGC process is awesome. And then actually, it's a crazy idea. There might be a room for interoperability experiment for lightweight consumer-focused SWE. right? It's yeah. I think this community, you know, we can get together, use these 2 days to talk about okay, how maybe we can do something in OGC process for lightweight and consumer oriented. Okay, so this is one good idea. Yeah. And then my next question, actually, I want to wake this crowd up. So, what? Actually, I went to IFTI, Münster last year, and Arne asked me a question. Do you see any business case, basically how to make money out of SWE standard? And I answered him, I don't know, but if you know, please let me know. If I know, I will not let you know. And but I would like to ask you, so do you see any business case or create monetary value from SWE standards?
If I know, I won't tell you.
I'm going to say the same thing.
Darn. But just
Well, entertainment.
entertainment.
You know, whatever road that will take initially. Gaming, VR, advertising.
Mm-hmm.
That's the obvious.
That's a tough question because business value is different for each community. You know, for a researcher is different from a private company trying to make a buck off of software is different from a government agency that's trying to enhance citizen experience and reduce cost.
Yeah, so actually, one business case that sort of works is smart grid and energy consumption management, and where you can orient your solar panels the right way, or somehow configure the grid so that it responds to the current conditions. Yeah, that case has been more or less well described. I'm not sure how successful financially.
There's two ways, isn't there, to make money off the sort of new or wet, right? One is through advertising, the other is through transactional costs. So how can you apply those models to networks of sensors to provide useful information that someone will either pay for on an ad use basis or that will go there often enough that you can try and market things to them? You know, that's the question, but
Yeah.
Well, if you look at content providers, you know, Digitalglobe, now Trimble, they're an OGC member, GeoCENS, and some of the other satellite content providers, they've all implemented a variety of OGC standards. Not necessarily the SWE standards yet, but why did they do it? I mean, how does it affect their bottom line? They do it very simply because they have found it's much easier for them to deploy a web services platform for folks coming in to buy imagery or place orders for imagery or a variety of different applications. So it's enhanced the user experience, which allows them to maintain their customer base and expand their customer base based on good recommendations from the installed customer base. And it also allows them to plug into other infrastructures. And for these organizations like Digitalglobe or GeoCENS, their big consumers are various government organizations that are now also specifying use of a variety of standards for their web services platforms like NGA or NOAA or Ordnance Survey or British military or going on. And so now they can plug directly into those, so they are reducing their integration costs because they're not dealing in silos anymore. So they can implement once and deploy many times, which reduces their cost of business and makes them more competitive in a procurement situation. So again, there are many different ways to look at the same.
That's a reduced infrastructure cost.
Reduced infrastructure.
Money saving.
Higher profitability, really, rather
Yeah.
than direct consumer pay.
Yeah, ideally in a situation when openness gives you some additional benefits. Because in many cases your reduction in infrastructure costs or additional information that you get from sensors may increase your competitive advantage, right? But you may not necessarily want to make it open. Right, so if we look at business case where money is like futures trading, agricultural forecasting for futures, that's where sensors can be, but that part may not necessarily be made open by people who do that. If we can find a case where openness would be of greater value, and this is maybe the case again for health and medical records and environmental impacts. because medical records is
Yeah, recently I heard a SWE friend, he's moving to medical stuff. Anyways, I want to open the floor. So do you have any questions? I mean, please fire. Oh.
Wow.
Wow.
Can you comment on the potential and perhaps ongoing convergence of SWE and OGC standards with relevant ISO standards and other standards that are working in the same area?
It's a common question.
Does ISO have any sensor standards?
Well, it has metadata standards that apply to things like location and data quality. And
okay, so you are talking about the TC211.
you tell me.
Okay. ISO has technical committees, one of which is called TC211, Technical Committee 211, Geomatics. They actually formed in the same year as the OGC. And they're developing a suite, or have developed a suite of abstract standards, okay, for a variety of topic areas, one of which is metadata, which is ISO 19115. And part 2 is imagery, so they have stretched a little bit into the imagery space. They have another ISO standard in progress for defining the characteristics of imagery and how it was collected, including the device that collected it. That again is an abstract model. You can't take one of those ISO TC211 standards and say, implement it. As Ilya pointed out, they're general. Therefore, you need to sit down and talk about how you're going to actually do something for your environment. Now, the OGC has a class, it's called Class A Liaison with TC211, so I go to ISO meetings and their representatives come to our meetings and we share documents, and OGC standards become ISO standards and ISO standards become OGC abstract topic volumes. So there's a really strong synergy between the two, and what the OGC quite often does is takes those abstract parts and turns them into things you can actually implement. Like GML, geography markup language, is based on half a dozen ISO standards as the abstract model. So there is a lot of synergy there. But they have not gotten down to defining suites. As a matter of fact, they want us, OGC, to take all of our suite stuff into ISO and make them ISO standards.
That's a good thing.
That would be good.
Any more questions? Come on. Yong.
Is there any either lighter SWE or broader SWE kind of thinking? Like, so OGC has other standards like deal with like web mapping service, for example. Is it part? It's not part of officially SWE, right? But is it because SWE only deal with a very narrow definition of sensor, or is it? I'm just trying to figure out in the future when people actually want to use this a lighter or broader defined sensor definition, then basically all kinds of data, including those geospatial data and maps, become part of the sensor data source. So how do you think about that kind of integration synergy, especially from a user perspective? We need to deal with multiple standards, and there's a divide between, like, for example, the SWE standard and other grid data or actually map data, for example. But we need them all, actually.
That's a big question.
Well, I mean, yeah, it is. I think SWE is just an interesting partition within the OGC framework for particularly sensor data. But in reality, when you want to deal with real operational systems, you use the full suite of OGC services within SWE and without SWE. So in our case, for instance, we would use a bunch of things from SWE, but we would also end up using other things from the OGC stack, like WFS, WMS, to really build operational systems. So I think the SWE part is just the packaging. with respect to the light, I think that's just an idea that I threw out. I'm not sure that there's anything happening there. I'm not sure it's viable either. But it's
Starfish fungus.
yeah.
Yeah, the first presentation on tomorrow's SWE session is Star Funders. It's an advertisement.
I may be wrong, but I think the SWE standards were brought into OGC as a package. No? They all the work
They started
independently,
independently, but they came together into the SWE main working group.
Okay. Yeah, but the origins were in other work, right, in Alabama.
Yes.
Yeah. And of course there is some dichotomy when you talk about exchanging more traditional standards geospatial data and versus time series or time dependent data. So there is certainly some logic in having observations separate at this point because there are always timestamps for observations. That's one of the key characteristics, and that's not necessarily the case of other standards. But indeed, when you build, Boyan said, when we build larger architectures that involve spatial dependent time series, for example, and time series collected at different locations, then all of these standards have to play a role.
So one of the problems I think is there, and this is recognized in the W3C work in semantics sensor networks, is that sometimes to get clarity about where your sensor standards begin, where the other standards lie, and what the relationships are, you need to have a clear conceptual model of what it is to be sensing something, what those things are. And that allows you to split it off from the other things. And so right now, there's still quite a debate about what does it mean, as I mentioned earlier at the beginning. You know, what is sensor data? What fits under that stack of things? It's not totally clear yet. So I think what we're missing is really a good abstract conceptual model that integrates the whole sensor arena with the abstract feature model of OGC, which relates them back to locations and basic features. I think that isn't clearly defined enough to allow the standards to necessarily be easily separated and maybe simplified. So I think that might be another iteration of things to come, and it's already starting to happen within some of those groups. Carl?
It may be just as, yeah, exactly what it said. If you look at the definitions of the basic concepts that are, say, in a SWE, if you look at O&M, one of the key issues is procedure that you use to measure certain things, to observe properties, to come up with a result for a certain feature. Procedure is not necessarily the key component of, say, WMS, WFS type. So GeoCENS, it may be somewhere in lineage metadata or something like that. So it's just what emphasis you put on your key concepts, procedure, results of measurements, feature of interest, and what else is there? Yeah, the distance. There's of course overlap between them and what is used in other encodings, but the emphasis is on procedure and object properties. That could be one of the ways to separate them.
Any more questions? Ben?
I was wondering what your opinions are about having a reference implementation for some of these standards.
Yes.
So
Which actually gets to one of the questions we weren't asked. The biggest barrier to adopt, there were two big barriers, maybe more, to adoption. One is obvious, people just don't know about it. But then once you know about it, what's the biggest barrier? The biggest barrier gets back to this issue of perceived complexity, because if you just download the standards and start reading them, it's like, and you're going to toss them in a bin and try to do it on your own, which happens out there. So what we really need are reference implementations, and 52 North has some excellent ones, as does Ephesus for the oceans community, and NOAA's putting some together for the atmospheric community. But we need those reference implementations, because the first thing is, Huh?
You forgot ours.
Oh, that's right.
Yes.
Yours is open source.
Might be very soon,
Very
by
soon.
December, yeah.
Another reference. There are a number of reference implementations available now and soon to be available. Because when I was a developer, the first thing I ever looked at, I didn't look at the Fortran manual, and I'm dating myself. I would look at code. Here's some code that sort of does what I want to do. And, reference. So I can look at the code. Most developers like to look at code and say, oh yeah, that's what I want to do. I'll just tweak it here and tweak it there. And, which also brings in the concept of the need for tutorials. Again, 52 North is working on an SOS tutorial. It's partially online now. It's got a lot of really good stuff. Assessus did a bunch of tutorials and implementations in a variety of different implementation environments. And then the last part, which gets really interesting, and we're struggling with this in the OGC and looking for a solution, but like if there is a description of a sensor using sensor ML, how do I find it? Like most of the civilian satellites and most of the military satellites now have sensor ML descriptions, but try to find them. Yeah, I can go to NASA and ask for their sensor ML description of MODIS, and I can go to European Space Agency and ask for their sensor ML description of the Italian satellites or the French satellites, but if I don't know that, where do I find them? So I think another piece of the equation that we really need is a registry of a variety of SWE-related things, one of which is the sensor ML descriptions. Where do I get them, and what do they do? And perhaps SOS instances. Yeah, I know that sensor's out there. How do I get to it? I can go to NOAA and get access to their sensors, and I can go to GS and get access to their sensors, and I can go to Natural Resources Canada and get access to their sensors. But again, there's that missing piece.
Self-promotion again. Actually, one of our PhD students, she has a search engine for SOS. So actually there's API online. If you want to know where are the SOS, you just register API and then fire the query and you get it back. Okay? Yeah, try it later. Today at 5 o'clock.
Has she solved the stale or dead link problem?
Oh, we have the process to just test it. And we even crash some servers by testing it. Okay.
So there's another thing that we need in the registries. So those are all necessary, but because we're dealing in some cases with massive data sets collected frequently, we need some summary statistics about what's in the data to know whether it's even worthwhile going to that sensor. It's not enough simply to know that the sensor is there and does something. You'd want to know actually what types of data are in there, what ranges of data, to know whether it's worthwhile to go and pull it. So that also has to be added to some of the registry components.
Actually, I see that's a sweet spot for some SWE research here, right? Yeah, how to summarize it in a scalable way.
Yeah, I would say that indeed catalogs and registries is a very important thing. And in Quasi, one of the slides that I mentioned, that I showed before, the main focus has been on building catalog that will work across like 75 or more networks. And this catalog also works in a similar fashion to what, that's the catalog. In a similar fashion to what Steve just said, we query the services regularly. There is a way to see if they are up and analyze what kind of quality data they have that they produce. But ultimately, it is a question of what kind of information people need to do search, and for water data, what they want to discover. So in our case, and it's more or less a convention that we have adopted in Quasi, people look for time series that come from many different sources. If they would look for services, what would be the information from time series that we would need to aggregate in the services in order to make this search meaningful? And again, for different applications, this type of aggregation may be different. So it will be very important to have catalogs flexible and tunable to different applications.
Can I say something actually? In GeoCENS, in our research group, we believe in people are interested in data, but not interested in services. So scientists are maybe interested in observed phenomenon. So we believe that the system like with the registry or service like that, to aggregate different sources together, so allow people to say, okay, show me the air temperature, okay, and then show all the air temperature, not the services, but the readings. So you can, have this kind of discovery process over there behind the scene. So this is what we believe. Again, touch a little bit about semantics. I don't want to touch today, but
actually, that is a big research area that needs to be filled a little bit. Is user interfaces to this. There's more data, more types of data occurring more frequently, and useful ways to be able to actually look at it. I mean, people are touching on it. I know your group's done a lot of work and some others, but I still think there's a lot that could be done there to simplify that view and come up with different modes of viewing to help understanding.
Okay, I want to continue this one. The question is the biggest barrier, okay? And so Carl leads to this question, right? What's the biggest barrier for SWE? And then we'll go into what's your suggestion about the action item or sweet spot for research or development, okay? So any other major barrier for SWE adoption? So we know registry search, or I should say resource discovery is one, okay? And what's the next one? And we also know the reference implementation is one, so we need more implementations. We don't want to read spec, we want to read code, right? Or examples. And then the greatest standard is the standard, don't know it's there, right? And anything else we should do?
Scaling.
Scaling, yes.
Yeah, scalability. Because if you look at these numbers,
Yeah.
18,000 variables, you can't put this in a drop-down box, right?
No, you need a search engine.
And then how do you search? Because different groups mean different things when they say variable. Right? USGS calls it parameter, and CDC calls it element, and EPA calls it characteristic. And these are different conglomerates of variable topic, or whatever you call it, and some additional characteristics. So essentially it boils down to what is your conceptual model of variable, conceptual model of time series, and to observation of measurements.
Scaling in different dimensions, right? Yeah. Anything else?
Scaling in terms of number of sensors, volume of data, because the original standards were oriented towards small to medium-sized networks of data and sensors. And when you start looking at this, when you start looking at the networks that we have, there are some issues. Now, some of those are starting to be fixed in the newer releases, like SOS2, but not completely. There are still issues with massive data and massive sensors.
So my friend, scalability, good research issue for next week workshop submission. Okay. Okay, let's talk about pick one only, okay? The immediate action item. As a community, what should we do? Or next year, when we get together, what should be done?
Join the OGC and help us make them better.
Okay, that's one. Join OGC. Again, advertisement. OGC have a university domain working group, and I'm the chair. So we might do more activities there about the OGC research. So how to innovate behind the standard. So do join. Okay. Next one.
Most of the things that we talked about would take more than a year. But if within a year, some best practice papers or
engineering report,
SWE primers or tutorials could be produced. That would really help spread.
And semantics.
I think there's enough there for useful usage right now. I think the best thing that could happen is to broaden the community. Because I think the thing that will give it the most weight is having more data providers and more users.
And the value grow exponentially.
Because the level of development of the standard, despite all the things that we've been saying here, is such that they are usable in operational systems. It's demonstrated by Quasi and others, including ours. So I think it's more a matter of bringing the community closer together and making it bigger.
So 3 action items. First, join OGC, innovate behind the standard. Second one is, best practices, tutorials, engineering. In OGC term, that's engineering report, right?
That could be a primer.
Premier, okay. And the third one is community building, more data.
Bring a friend.
Bring up a friend. Okay. Tweet about it. Okay. Any more questions? Yes. Okay.
Are you all staying throughout the whole workshop, or are you leaving?
Yeah, they are locked.
We're enjoying the beautiful sunny.
Any more questions? It's a very it's very difficult to get all of us here. So let's use this time. Forget about this coffee outside. Okay. Any more questions?
Is anyone using SWE?
Good. Anyone use SWE?
1, 2, 3, 4, 5, 6, 7.
Alan?
Which components of SWE do you use?
Yeah.
Well, I'm making a talk tomorrow.
So you got to stay around the
And I'm in oceanography, and my big push was to flush out the describe sensor capabilities. We also do the O&M and big capabilities, but the big push was to do the describe sensor. Because there wasn't very many models for that.
Yeah.
So do any of the things we say resonate with you?
Absolutely.
Yeah.
So do you find describe sensor sufficient and flexible enough?
It moved me off my stovepipe.
Because,
Everybody
my-
says, that I have a talk tomorrow, so I'm going to.
Actually, George, first of all, strongly hinted me there is a potential master thesis about a simple profile sensor ML in JSON. Okay, just FYI if you're interested.